This is video 50 on a Home Assistant and embedded solution. Let's set up weather forecast for an LVGL display. Since we just did this for the Pico W, let's implement multiple pages in timeout. In this video, we learn how to get current temperature, a 3-day forecast, and a 3-hour forecast to our display. Please let us know in the comments about your home automation system. We welcome ideas. For this effort, we assume you have Home Assistant running. We deployed the latest 2025-08 Home Assistant on a Raspberry Pi 5 single-board computer. We have a minimal implementation that includes the ESPHome device add-on. Our test rig is based on an ESP32-S3 device, often called CYD or Cheap Yellow Display. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. Our goal is to get the default weather forecast data on our LVGL display. We will review the Home Assistant weather. We'll discuss data flows to an ESPHome device. We'll discuss multiple page display setup. We'll present the test rig wiring, and we'll walk through the configurations. The YAML files are at the GitHub site that's mentioned in the description and endnotes for this video. Essentially, we want the default weather data in Home Assistant to be fetched by our ESPHome device and displayed on our LVGL supported display. Let's look at the demonstration. What you are seeing is a blank display. That's because the page is paused. We can tap anywhere on the display to refresh it. Now you can see the current conditions and the temperature. We can tap the next page in the footer. Now you can see the daily forecast. This is for days 1, 2, and 3. We can press the next page again. And now you're seeing the hourly page. And that's showing the forecast starting from 4 hours from now for the next 3 hours. We can also press the previous page, or we can press the home page. So there you have it, a nice multi-page weather forecast. A new Home Assistant system has a default weather device and entity. You can click on it and get the current temperature and conditions, as well as both a 3-item daily and hourly forecast. The entity ID is weather.forecast_home. We can get the current temperature and current conditions on our ESPHome device as a sensor by specifying an attribute like temperature. Then we can update the text of a label with the value. So easy, right? Now we just need to get the forecast data. Well, others tried this. As explained in this forum discussion, this capability was deprecated in 2023 and removed last year, because the Home Assistant developers felt that this was a lot of unrequested, unneeded data transmissions that hampered overall Home Assistant performance. Now, one must specifically request the data in 2 steps. First, that begins by deciding what you want. In our case, in the previous video, we desired daily data. Now we want to include hourly forecast data. We can do this as a template sensor in the configuration YAML. Next, you define a helper, which is a configurable template sensor, which specifies the attribute you need. In ESPHome, a numeric value like temperature is configured as a sensor, whereas a text value, like a condition of sunny, is configured as a text sensor. Both can update an LVGL label. The developer tools are helpful in displaying entity values in order to verify configurations. Now let's look at the developer tools. There are 3 tools that we specifically are interested in: states, actions, and template. Let's choose states. Under states, we can see any of the sensors that are available in the system. For example, the default weather information is available as an entity called weather.forecast_home. Here you can see it provides a condition and several numeric values. Now we can look at actions. We can use actions to design our template sensors and a GUI. We do that by using this action button and searching for a function that we want to experiment with. In our case, we go all the way to the bottom and there's a function called getForecast. We can go into the UE mode and configure this function. First, we choose a target. We're going to use device. We're going to click on forecast. Next, we want a forecast type. Well, we want daily or we want hourly. So let's choose daily. Now we can perform the action. When we do, it gives us a data array that results from this running this function. We could even go into YAML mode. And what we get is the configuration values that we can paste into our template sensor. Let's go ahead and do that. To get to the configuration YAML to use this data, we click on File Editor. We can use the file editor to look at the files on our Raspberry Pi 5 system. There's a file called configuration YAML. If we click on it, we can see several default configurations already set up. In the previous video, we added this last line, which is template, and then include a file called templates.yaml. Let's look at it. Here we have the template sensor that we previously defined in video 49. This provides a forecast of daily data. In this video, we added a second trigger, which provides hourly forecast information, as you can see by this type here as we set up in the states screen. Now we have a new sensor called forecast hourly. And that's how these entities are named. It's sensor.forecast for this first one, and it's sensor.forecast hourly for the second one. Let's go back to our developer tools and go back to states. And let's see if we have those. So we can scroll down and we look for the sensors. And here's sensor forecast. If you recall, this is the entity that results from the daily forecast. Let's scroll down. And we also have sensor.forecast hourly. And this is the second template sensor that we created. This provides hourly data, as you can see. Notice also that the data is provided 4 hours ahead of our local time. All right, so that's the action screen. We can use it to test out our template functions. In the developer tools, there's a tab called template. Here we can write Jinja 2 scripts. These scripts are then placed in the second feature of Home Assistant called helpers. Helpers are template sensors, but they must be defined in this Jinja 2 syntax. Let's take a look at this. All right, with the state attribute being run on forecast hourly forecast, you could see I got the array of data. So now that I know I have an array of data using this Jinja 2 syntax, what I want to do is index into this. So this is hourly information, and there's multiple hours. So I can add brackets to define which hour I want. So in this case, the very first item, the first hour of data, which is 4 hours from now. Now I can enter in an attribute, in this case temperature. And bring it back. When I do, you see I get the real result 67. If I remove this, you can see 67 is right here. All right, now that I know how to use Jinja 2 and create a helper function, I can create the helper functions. And I do that by using the settings button. I go into devices and services, and I look for a function called, I look for the tab called helpers. Here you can see all the helpers that we created last time. Now we want to create helpers for the hourly forecast information. Let's select one of these and look at it. We can look at the configuration by clicking on the gear cog wheel. Scroll down and you'll see something called template options. Here you see the Jinja 2 statement that we saw earlier. Here I'm getting from the forecast hourly data the condition in the first hour. I don't need to use any of these other items since this is text. Let's take a look at temperature. All right, here's temperature. We can click on its cog. Notice the difference is, and you don't have to do this, but it looks nice on the Home Assistant display. I entered in and chose all these unit of measurements and whatnot. Here you can see, just like we showed in the developer tool screen, is that Jinja 2 statement to get the temperature. Now we don't have temperature low because that doesn't make sense for an hourly basis. But we do have one other piece of information that would be interesting on our display, and that's time itself. So that's why I created these 3 extra helpers right here. So let's look at the first one. So here's template options. So let's look at this function. You can see I have the state attribute, sensor forecast hourly forecast. I use our index of 0 to get the first hour's data, and then I use daytime. That's one of the values in there. Now I don't want everything from the daytime because it's mostly zeros. So I just index into that string and give the characters 11 through 16, and that gives me the hour in minutes. But this is a string value, so we have to use a text sensor eventually. All right, and that's how we've got all of our data into the system. We can look at an overview, and it shows all this data. So now we have all the hourly and the daily forecast information available in the system. And we can use this on any ESPHome device. So this is at the Home Assistant level. Designing the display will be fun, as every object is just a label. In our previous video, we designed the screen shown. But now we will split this information across 2 pages and add a 3rd page. Notice that we can size the width and height of the labels for each track of the Flex flow layout, and then simply position them sequentially in our configuration YAML. On this slide, we show the pins used in our test rig based on the cheap yellow device documentation. The display's backlit pin is pin 21, and we must include it in our definitions. As you can see, we can turn it on from the Home Assistant display, or we can turn it on by touching the screen. Okay, back on the Home Assistant system, we select the ESPHome builder, and we see all of our microcontroller devices. As you can see, we added an ESPHome device called ESPTemp. Now let's walk through the device configuration. We do that by clicking on the Edit button. Here we have the standard setup for a ESPHome device. When you set up a new ESPHome device, you do that in 3 steps. First, you create the initial YAML. Then you come back and add the manual IP. Then you should go down to Settings, come over here to Integration, add a new integration, enter in ESPHome, and now it's going to ask you for the host. Here you put in the IP address of the new ESPHome device that you just created. You do this so that the ESPHome device can interact with the home automation system. All right, let's go back to the edit. All right, now that you've done this 3 times and you have the ESPTemp YAML set up so that it's able to be updated wirelessly, make sure that you have entered in a web server port, because that is required for ESP. You can also enter in authentication. I just didn't do that in this particular case. Now we're ready for the hardware setup. The next pins I got from a forum discussion, which I'll put in the endnotes and the header, the video description. So this information provides us with all the pinouts needed for the SPI, for the backlight, for the display configuration, and for the touch screen. Up to this point right here. So you must enter in all this information and then test your display with a hello display. Just put a single label that says hello world. And I'll put an example YAML out at the GitHub site. Here I've added to the touch screen the ability to resume after it's been touched. So if the display was paused, which you'll see why it is, then you can resume it. I put out a message in the log. I turned the backlight back on, I resume the display and I redraw it. Now we have the sensor definitions. This first one is using the weather forecast home, which is the default. But the following sensors are using the helper functions that we created. So the first set is the helper functions that we created in video 49 for the daily forecast information. And then at the bottom, you'll see of this list, you'll see that I added sensors for the hourly information. Next, we have the text sensors. Again, we have text sensors for information that's textual. So the conditions are all in text. Here, I noticed that I could use an if statement to return a font value that represents a weather condition. The other thing I did is I could use that if statement to change the color. So here you can see if it's sunny out, if the condition is sunny, I change the color of this icon to yellow. Then I copy and paste this for each condition. Okay, now I have a section on fonts. And these are some example fonts as a Google font. So there's a file called Material Design Icons that provides all these weather icons. And this file is available in the GitHub site. You will need to load that onto the system and put it into a folder called Fonts that's under the ESPHome folder in your Raspberry Pi. Finally, we come to the UI information. Now we have the displays and the touchscreens, which were defined in the hardware section up above. But notice that I set a timeout on the touchscreen. So after 5 minutes or 300 seconds, it's going to turn off the backlight and pause the display. And you can refresh it by simply touching the display. Then I have these style definitions, and I got this from the online documentation. This is the style definition for the footer and for the header that you're going to see on every display. So next we have what's called a top layer. And this is the footer that's going to be on every display. It's defined as a button matrix. So it's going to have the previous button, the home button, and the next page button. In this definition, we have the actual navigation to the specific pages. So for example, the home button is defined to go to main page. So that's the very next item that we're going to define in the LVGL script. Notice that for the previous and next pages that we don't have to give a specific page, which is really nice. It just knows the order in which you've defined these and knows which page to go to when you say next page. The important thing is that these all line up at the same level. It's really hard to track that. So you can utilize the feature that you can see here. As you scroll, it saves the last couple statements, allowing you to line things up. So here's the main page. We can line that up with the day page. See, here's the hyphen for the main page, and here's the hyphen for the day page. And now keep going and bring in the hourly page as well. All right, so there's the hour page. All right, let's look at the main page. The main page consists of this header section, which says main page. Notice it uses that style that we created above. And that's it. And then it has an object. So this object is the Flex Flow Layout object. And notice we're using row wrap. And this is the same thing that we did in video 49. The other thing I did is I set the width and height differently than I'd had in video 49. In video 49, we used the entire page, but I want to squeeze this information below the header and above the footer. So I give it a height of 156, and remember our display is 240. And I begin it on line 12. So that allows us to center the flex layout labels in the middle of the display. All right, and so what do we have? For the main page, we just have 3 labels. We have the icon label, the temperature label, and then the condition. All right, so here's the day page. So we began with the header object, which has the name daily page, and then the object to hold the flex, the object that holds that which is the container that holds the flex labels. And you see underneath it is all these widgets that are the labels that are within that flex object. Then we come to the hourly page, and you see we do the very similar thing. Well, that's it. That's how we configured the display. So, in summary, in this video, we demonstrated a multi-page forecast display. We discussed the Home Assistant weather forecast system. We presented the Home Assistant template sensors in 2 steps. First, in the configuration YAML, and secondly, as configurable sensors within the helper of the integration display. Then we demonstrated some of the developer tools. Finally, we walked through the configuration of the CYD device. The benefit of all this is a better understanding of the Home Assistant templating and the LVGL Flex features. Please comment if you feel other changes are needed. I hope this video helps you with your Home Assistant ESPHome LVGL programming. Thank you for listening.